All right, 61. Clearly a question from chapter 8, right? It says if the graph of an exponential function passes through the points 1, 6, and 448, write an equation for this function. Super! That sounds like fun. So I'm going to look at this in terms of an XY table. And I don't know the zeroth term, but apparently the first is 6, second, third, fourth is 48. And we're trying to find a function in the form y equals ab to the x. I'm assuming because we have not been adding a plus c here that we're not going to be shifting anything up or down. We'll just be looking at a situation where the x-axis is an asymptote for this function. So two ways to do this, and I've illustrated both ways. One of them is to just kind of reason with the table. And if you're comfortable with that, I encourage you to think about the table, but I'm going to write a system of equations and solve it. It turns out I have two different x, y values. X is 1, y is 6 from one, x is 4, y is 48 from another. I'm going to write two different equations. So the first one I'm going to write is y, 6 is equal to a b to the x power of 1. And the other equation I'm going to write is that 48 is equal to a b to the fourth power, right? So this is a system of equations, and we can solve this by the first time we saw this in class, some of us tried to solve it using the subtraction property of equality. The problem with that is there's nothing added to either side, right? It's just a single term on each side. So just things that are multiplied together. There's just a single term, right? That's comprised of factors. So what we have to do instead is we have to get a alone in one or both of the equations, and then use either the equal values method or substitution. So by that I mean I could take this first equation and I could get a alone by dividing both sides by b. So I could write 6 divided by b to the first, or 6 just divided by b, is a. So if you look closely, what I did was I took 6 equals a times b and I just divided both sides by b. Now that I've done that, I've created an expression that is equivalent to a. This thing that I've just boxed is the same thing as a. And this time I'm going to go ahead and choose to do substitution. I'm going to replace this expression that's equivalent to a for the a that is in the second equation. So this is substitution here. So I'm going to write the 48 equals, and then instead of writing a, I'm going to substitute in 6 over b. And then I'm going to multiply that by b to the fourth power. And I'm intentionally writing like this because I want you to understand that b to the fourth power is b to the fourth over 1. It kind of helps clearly see the fact that these factors of b, the four factors of b, are in the numerator. So b to the fourth over 1. Now I can clean this up because I could write this as, well, that's equal to 6b to the fourth over a b, right? Which is what? That's the same as 6, not b, that's the same as 6 times b to the third power. So to isolate b to the third, I'm going to divide both sides of that by 6. So 48 divided by 6 gives me 8. 8 is b to the third. And I know that b in this case is just, b is just the number 2. Right? I know 2 times 2 times 2 is equal to 8. The other thing I could do, of course, is I could raise both sides to the 1/3 power. So if you get a situation where you don't have this memorized like we do here, you could raise both sides of this equation to the 1/3 power. So I can raise this side to the 1/3 power, and I could raise this side to the 1/3 power. And the reason why I selected to the 1/3 power is b to the third raised to the 1/3 is just b, right? That gets it alone. And then on the other side, I evaluate b to the 1/3, and I see that that is equal to the number 2. In fact, let me try this with this scientific calculator just to see if that works. I'm going to take 8, and I'm going to raise that to the power of, I'm going to open parentheses, and I'm just going to go 1, oh, not 11, whoops, 1 divided by 3, close parens, and I press equals. Yeah, 8 to the 1/3 power is the number 2. All right, so we know what b is. B is 2. Then the question is, well, what's a? Well, a is going to be pretty easy to find, right? Because remember, oh, look at this. Isn't this delightful? This says a is 6 divided by what b is. Well, b was the number 2, so 6 divided by 2 is 3. So we have both parameters, right? We now know that a is 3 and b is 2, so we can write our answer. Our answer is y equals a, 3, times b, 2, raised to the x power. A times 3 times 2 to the x power. And sure enough, if I come over and I check this out, if I put the number 1 in, right, when I put in 1 into that function, that gives me a 2, and 3 times 2 is 6. If I put a 4 in there, let's see, 2 to the 4th power. 2 times 2 is 4, times 2 is 8, times 2 is 16. And 16 times 3, I'm checking it, but yeah, 16 times 3 is 48. So this solution that we've written down here does satisfy both of our equations, right? It works for the point 1, 6, and it also works for the point 448.